Yeah, thank you very much for this very lively talk. And are there any questions? I see one hand raised by Luca. I guess, Matthias, do you want to take over?
So, Luca, please.
Hello?
Luca Ghionghelli?
Yeah, can I ask?
Yes.
Hello?
We can hear you.
Ah, okay. Okay, so hi, Stefano. Quite insightful. I actually liked a lot your motto, symmetry is all about tolerance. It can go beyond material science. Or maybe also the opposite, tolerance is all about symmetry. But my question is another one, is about the uniqueness of the assignment in these AFLOW SIM. So imagine a very distorted structure, and I can think that one can think some very distorted structure as certain structure, certain symmetry A with a large distortion, or another symmetry B with maybe smaller distortion or something. So if at some point when the tolerance is large, if you can have overlap between two possible symmetries and actually get some probabilistic assignment rather than just one specific assignment.
Can you hear me?
Yes, we can hear you.
Okay, so Luca, yes, the good question, and yes, you can have. Okay, so scanning remember when you do the scan of the tolerance, for every tolerance that you identify in the real space is associated tolerance in the reciprocal space. You have operation in one, operation in the other. So you find the regions of tolerances where all these operations are compatible. Okay. Then it is possible that this region is, there are more than one regions, okay? It is possible, right? Because if tolerance is big, everything becomes cubic, right? So in this case, we pick the smallest possible tolerances, and where you try to reduce the, where you have the least possible amount of operations, but you also inform the users that there is another self-consistent solutions. It usually does not happen, but there are cases where it happens. That's correct. So when it happens, it's very few cases, like a handful of cases in the ICSD database, you get the two results. The code tells you that there is another accumulation point for the self-consistent code, for the self-consistent algorithm. Yes, that's correct. Okay. And it will be up to the user then to decide what it is.
Well, sure.
But the results, one choice or the other choice, they're both circumstances, meaning that if you choose if you choose one solutions, your Brillouin zones and your operations, they will be well defined. If you choose the other solution, will be something else. Okay.
Okay. Thanks.
All right, thank you. I do have two questions now here in the Q&A. And the first one is by an anonymous viewer. And it says, could you talk a little bit more about how to compare two similar structures?
From a computational point of view, or from a conceptual point of view? Well, computationally means that, okay, so well, this person needs to read the paper. It's actually very simple. And, okay. And if this person sends me an email, I will forward the paper. Right now, we are resubmitted to the reviewer. So there is a command, there is AFLOW, then there is the file. This is the first file, the first postcard, and the second postcard. They can be in any format they want, right? And then if that is the answer, the question, and then the code is going to tell if these two structures are the same. Or if it has a list of structures and you put the first one and then the other ones separated by a comma, then it will find which one is where, right? Okay, then, or there is an option for grouping. You have a list of structures and then the output will be group 1, group 2, group 3. So there are a lot of options, and I don't really know what is the questions, but if the question is about the operations, there is the README, and also in this paper, which I can share, no problem. We're going to put in archive one of these days. There are clear instructions. There are 2-3 pages of clear instruction and examples how to operate these things.
Okay. Well, maybe
it's simple. It is simple. Yeah. It is a little tricky, but it's simple.
Okay. So I guess your hint of writing an email and getting the paper beforehand, yes. That's great. There's one last question that I see here and by Tamas Harashti. And he says, he writes, thank you very much for the nice talk. In relation to one of your closing sentences, if we go for more automatic processing, how would you envision the feedback allowing for the control of the system? I mean here, quality control.
Your quality control. This actually relates to the question by Luca. If you have one answer, that's the best answer you can get. If you have more than one answer, then you might also need user operation, so intervention. We rarely see this, almost never, but it's possible. So the quality is that we are to be as close as possible to what people study by hand. And that's so once we have the results that are in literature that are hand curated, then we try to reproduce them because we believe that they are the correct ones. Occasionally we find mistakes, you know, the ICSD database has mistakes and we are able to fix them. Okay, so there will be options for the user to intervene and stop the flow or adapt to his or her own needs. But more or less, the flow can be done, let it go automatic, and you're going to have all these groupings, all this identification automatically.
All right.
It's like face recognition, you know.
Yeah.
There are people that look similar, even if they are not brothers, right?
I see. Crystals being faces. Thank you very much for this very nice final word. Okay. Yep. Bye bye.